Right. So good morning and welcome to the NEBOSH Environmental Awareness at Work certificate. So for those joining us, I guess on the online forums anyway. So this is a short NEBOSH course, and we would have covered in the previous recording lesson 1.1 as well as a bit of 2.2 that dealt with the safety aspect as well as the safety impact, right? And well, the health and safety and environmental aspect, and should I say the health, safety, and environmental impact, more so environmental. So if anyone missed it, right? If anyone missed it, the main thing you need to know about aspect and impact is that the aspect is like the cause, right? The aspect is the cause of pollution, if you want to think of it like that, then, right? The aspect is the cause, and the impact is the effect. So there are a lot of questions on that, like if there is, I guess I'll say the one from last week. If there is, I guess, smog or air pollution or some sort of, dust cloud, the aspect would be like where that smog or where the dust cloud is coming from. So if it is like from a chimney, a factory, you can say that the aspect is like the chimney that, of course, may be connected to um, some sort of factory that is burning fossil fuel, right? So that's the aspect. The aspect is the cause, and the impact, what the impact is on this slide, the impact is the effect. So they say the impact is any change, adverse or beneficial, to the environment. And of course, it's caused by the aspects. So if we look at that same example in terms of the smog, we can say like an impact could be things, I guess on humans, maybe things like difficulty in breathing, asphyxiation, increased cases of, mild asthma. And to the environment, it may be acid rain. Smog may contain some of those gases like hydrogen sulfide or nitrogen oxides, and those gases do tend to dissolve in water and could actually, fall back, I guess, to the earth as acid rain. And the acid rain would, of course, cause, damage to the leaves of plants. It would upset the water quality for fishes and other marine life, right? So when you talk about impact, the impact is like the damage, leaves, right? A disruption to the ecosystem. In short, things like dead fishes and stuff then, right? So the impact is the effect. So we did that last week already. And I was hinting in the first recording that we do something called an environmental impact assessment. And of course, those of us in the class here, we would have our textbooks. So even though it may look a little bit small on the view here, you could find this in your book. You could find it on page 20, or is it page 29? It's actually page, well, it starts at environmental impact assessments, or risk assessments, actually starts at page 28. Page 29, page 30, you'll probably see the same sort of diagram there. And of course, this is the, I guess I'll do a plug here for NEBOSH. This book is actually from NEBOSH itself, right? The NEBOSH Environmental Awareness at Work. If anyone wants to get it, you do not really have to, come through the school. NEBOSH website has a shop facility. Anyone in the world can just put in NEBOSH home. You get the NEBOSH homepage, and there's a shop facility there, SHOP. You can shop for your own textbooks if anyone, is desirous of getting a book who not currently enrolled in this semester anyway, right? So I was saying, if you have the book, you'll see, I was saying some weeks ago that there's something called an environmental risk assessment, and the headings for it are different. So literally these words you see in here, these words then are the headings of an EIE, right? So you start off with the source, which is the aspect. Instead of saying the typical risk assessment like hazards and stuff then, but you do an an environmental risk assessment. So you start off with the source, then the next column will be pathway. The next column is receptor. The pathway is like the routes of entry. For those who are accustomed with a safety risk assessment, the pathway is like how would it get, like from a smog, how would it get then, to affect the plants and animals? The answer would have been, it would have probably been dissolved in rainwater and, fall as acid rain. So that's the pathway, right? The receptor will be plants and animals, right? So you see here they have receptor. If you have the book, like I said, page 20, well, page 30 now, 29 is where they explain what is source pathway receptor. Page 30 is where you have the same diagram as here, right? So you'd see the receptor, they have their local residence, but remember we want to do more like an environmental risk assessment. So we can say local residents, yes, but then you have to bring it down to flora and fauna, plants and animals then, right? If you're doing an environmental risk assessment. And then you come to the impact. I guess the impact, they have spoken here about a local factory. I think it's the same sort of example. It's created smoke. The smoke cause could be a nuisance. So some of the impact could be, they say here, dirty washings, meaning like when you hang up your clothes, and this is quite a Caribbean thing anyway. If you hang up your clothes to dry anyway, then dust and the smoke and stuff could get onto that. You have health, you have asthma, and of course you'd notice here that they did not consider the environment. Right now they would have done it on the slides coming up. So the impact would have to be, things like the impact in short then, for those who are here for the first recording, the impact could, let me just say it simple first and then I'll say it a little bit more deeper, right? So the impact to the environment have to be to land, water, and air. You'll see it on the slides coming up, right? Or air, water, land, whichever way you take it to be, right? And then from the first recording, we also saw the impact could be both local, regional, and global. For example, the acid rain could possibly be local, but then clouds can move, especially if your country or your state is close to another country or state. Like Canada and America, pretty much Canada, America, Mexico pretty much is connected. We are pretty much here very close to Venezuela. So, clouds can move if it was, an acid rain sort of cloud and that moved into Trinidad, or from Trinidad moved into Venezuela. So the effect could be regional, and of course certain types of contaminants like the ones that cause like carbon monoxide and responsible for the increasing of the earth temperature, thereby resulted in global warming, could actually be a global effect, right? So I hope you get it. I was trying not to write it because it's gonna slow me down, right? I just repeated that in doing an EIE, you want to consider these as your heading for the risk assessment, right? And guess I'll have to write it a bit, right? So, but I'll just try to write the letters though. So for a risk assessment table, we are saying that you want to get the source, which is the aspect. The source is where the contaminant coming from, right? Here they have smoke and grit from a coal fire boiler. So the boiler in the factory here is the source. The next thing you want to get is the pathway, like how is it going to affect you, right? Is it going to be released through the air? Is it going to be as it was discharged into maybe a water course? It got into the food chain, for those who remember that from lesson 1. And then the same idea, like a small fish, a bigger fish eat the smaller fish, then a human caught the bigger fish, right? So like what is the pathway then in which in this case humans would be affected, but also the same for plants. If something is discharged into the water course, plants would absorb nutrients through their roots, so then it gets into the plant, it gets into the fruit, etc. So we have source, pathway, receptor here, and remember what I said, you want to consider humans, yes, but you also want to consider flora and fauna, which is plants and animals if you're doing an EIE. In other words, it's a very good EIE that it considers the environment. We want to consider the impact, and again, this could be to humans again, but you want to consider, I guess the land, the air, right? And maybe the sea. You want to consider these effects. You may even want to consider things like a local effect, a regional effect, and a global effect, right? So this is what makes a very good EIE. And just to finish the channel, the reason why I went to the marker is because remember you really had to work on the risk still. You had to work on the risk value still, right? So like those who are familiar with the risk matrix, you work on the risk value, like what is the likelihood of these things happening? What is the severity? You can go back to a 5x5 matrix, right? And so after you get a risk number, I'm just gonna say, let's say it was acid rain from one of this same thing here. I mean, if you look at asthma, but I want to go to the environment. I don't want to do a safety risk assessment. I want to go to the environment, right? So if we say it's something like the impact could have been, like acid rain, so I'm going to go to this one. We say how likely it is. Now, this is a made up example, but if we, I guess, stick to this one here, they are saying that there's smoke and grit from a boiler. So I'm going to say maybe the likelihood is about 4. The severity of acid rain, I guess, if you remember, this is done for plants. We're doing this for the flora and the fauna. And this risk I've done here, I'm not really doing it for a person, right? I've come to the cloud then, right? So I'm going to say maybe 4x5, and that is pretty high on a risk assessment. A risk assessment is out of 25. The highest number you can get on any side is 5, right? So this is 5. This would be 5 as well. Kind of out of space though, right? So 5x5 is 25, right? So the highest you could ever get is 25. So 20 out of 25 is bad. Normally what you have to do then when this happens is that you have to control that risk. So those of us familiar with the typical risk control or the risk matrix, the next thing you have to do here is after this risk turns out to be 20 out of 25, you have to reduce, like the chance of that happening, right? So see if you can see it. It takes on the same appearance of a risk assessment. And I did mention, those of us who are doing like environmental management systems, this is what you really do. And of course, in Trinidad here, we have the store management system that element 8 of it requires exactly what I'm telling you all here, environmental risk assessments. And I also mentioned that element 5, I don't know if anybody bothered to open or try to download this store document. Just give me a minute, I have someone to admit, but the Zoom bar is in the midst of where I have to click, right? So let me just maneuver this a bit. Right, so I think I got in Vanessa there, right? So yeah, and I have to get back my marker, right? So hopefully you saw it. I have some really good ones. Remember I do consultancy. I did one for, well, whenever I do store for companies, I make sure to get element 8 really looking like environment then, because I did say to you all, some people try to pass off a risk assessment or a safety risk assessment for an environmental risk assessment. But the thing is, it have to, in other words, and I was saying in recording one, that it really have to look like the environment. You have to do consider, like air, water, and land. You're not just to consider persons alone, but you have to consider flora, fauna, the natural environment in air, water, and land. So that is what makes it an environmental risk assessment, right? Once you're in safety here in Trinidad, of course, and you are in a company and they are still certified, you're gonna have to do these things anyway, right? And you'll be, I did mention to you that the auditors are very happy when you use the words, when you use the concept then of an environmental risk assessment as opposed to passing off a safety risk assessment for the environment, right? In fact, it's not meant to be like that, right? The concept of an EIE is a little bit different. Principle is the same as a normal risk assessment, but we do have to sound then environmental-ish anyway, right? So hopefully you got that. And those of us who know the risk assessment, just let me finish up the table. Normally when you put your controls in place, you'll have to go and work over the risk value again. They refer to that as residual risk. And then you normally would end this table by saying who is responsible and by when, right? Who is responsible and by when would action be taken? And that is the format for your environmental risk assessment, right? So moving on, that is away from page 30 now anyway. If you have any questions you could ask, I don't, I mean, like for this level of the exam, you know, it's not as if they're going to get you to do one. I think we sort of did it like that because of the requirements here in Trinidad, because of STO. And, you know, just to make sure that you all are aware that it's not the same as a normal risk assessment, right? But we have seen the exam questions already. Those who were here last week, at least I'm trying to come up to it. Let me see if I could come up back to the question. There was a question, and normally the questions are, you know, like what is an environmental aspect? What is an impact, right? Let me just continue a bit. So other sources of contamination from the chimney are carbon dioxide, contributes to climate change. Sulfur dioxide reacts with water to create acid rain, right? And if you know a little bit of chemistry, I wouldn't go into that, but that is what that is. You could actually prove that. I could actually prove that to you if you write the chemical equation for it, which I wouldn't do at the moment, right? So this was, I think this is how they had theirs on a table, however incomplete it was. So I guess I could just, let me just go to sulfur dioxide. So the source of the contaminant, this would be the aspect, it's coming from the boiler, I guess. So the contaminant, the sulfur dioxide, the pathway, it's a chimney to the atmosphere and then deposited as rain, acid rain over Scandinavia, right? And so that's how it gets to the air from the chimney to the atmosphere. From there, it dissolves in the water and I guess it falls. They said deposited, right? I would have said fall as rain, acid rain, sorry, over Scandinavia. The receptor, so you see why I've gone to this one, because the receptor is a tree, you know, and as I said that in environmental risk assessment, you want to consider flora and fauna, right? So they consider is the Norwegian trees and the impact is forest dieback, right? Forest dieback is it's damage to the bark of the trees, right? BERK, the bark of the trees anyway. If we go to another one, let's just do the one with fishes again. Sulfur dioxide, the pathways, the chimney to the atmosphere. So again, if this was a vessel and there was an oil spill, you know, like the pathway, well, the vessel is going to be the aspect and this and the leaking pipeline or whatever, right? But you know, I guess, sorry, the leaking pipeline could actually be the pathway. So leaking pipeline that runs into the sea, right? And that would be the pathway. The receptor again could be fishes. We have it in Norwegian salmon. The impact is, well, I guess, declining fish stock or dead fishes, right? So what they didn't do here is they didn't do the risk, nor did they put in the controls. Now they commented, though, that's the thing. I mean, as a level 2 course, then they didn't tread too much on the degree. Remember, there's a degree in this, but they didn't tread too much in the environmental degree. But they did cover it. Like, as you turn the page, you would see controls. They mentioned the hierarchy of control. You know, like the way to control anything there is to try to eliminate the source of it, then substitute, then engineering controls. So all of that is coming up, hopefully, if we can move on, right? So next thing here, I guess you have to turn the page. You have the cradle. I guess this is part of controls, to be honest with you. This is, some of it is nicely shown on page 31. I guess in a way, the cradle to grave concept is hinting on controls. So if you want, you know, we could, I'm trying to see if you read anything from the book for you anyway, but the cradle to the grave concept is basically controls, right? But they are taken care then of the contaminants from the inception to final disposal. If you look at page 31, I don't know if I have the chart as well. Yes, I have it, right? So the cradle to grave concept is that contaminants or pollution or sources of pollution then are dealt with from the very extraction stage to final disposal, right? So that is called a life cycle analysis. And it's like a good part of a management system then, right? So I would want to say here, I guess, well, for those who know, right, that Trinidad, we have an environmental law, the Environmental Management Act. I believe, I'm not too sure if they are functioning, but I know that they are environmental officers or police, literally police, right? But one of the things, of course, you know that the Caribbean lack is implementation, right? So in the UK, just to give you a comparative here, in the UK, in addition to their environmental act, they call it the EPA Act, EPA, Environmental Protection Act. We have ours in Trinidad, it's called the Environmental Management Act. But just like those who did other courses with us, that you'd know that the UK have more than one laws for the environment then. It's not just the main act, right? But there are many regulations that govern the environment. And the long story, the end of the story here is that those regulations then make it a must, right? It's a must then that employers or manufacturers that they track their products. I think we even did one last week when we spoke about B&Q, right? Where B&Q had to say they were getting, like where they were getting their trees from to make furniture. So you would have, if you read that over, you would have realized that it was a pressure put on them. Part of it was like a regulation, and the other, of course, would have been, you know, customers wanting a safer product, right? So um, so just take it from me that there is, so there are regulations that make this thing an absolute duty then, right? That these things must be tracked, right? I was looking at not now, of course, I was looking at this show on cable, Ice Road Truckers, if you all have ever seen it. I remember seeing a film in it, and again, Ice Road Truckers is in Canada, right? Well, parts of Canada anyway. Just a long story short, in one of the episodes, one of the drivers didn't maintain. There's something called a consignment note. Like if you are carrying products, then you must. That's how they. I mean, this is how they track it. If you wanted to know, like what I mean, like how do they track where a tree is coming from? Where is like a washing machine being sold? Who is delivering the washing machine? They have something called a consignment note, right? That is passed on then like from the shipper, right, to the person doing the delivery, to the consumer, and again, in the UK, passed on maybe to your recycling facility. So they track the whole life cycle of a product then, right? And in that, one of the episodes, a driver made a long run and somehow I don't think he had the consignment note with him. And you know what happened if anybody had seen that film? The authorities or wherever he was going, they seized the truck, right? They seized the truck because remember what I said, it's an absolute duty. Absolute duty meaning you have to do it in the law. They seized the truck and they seized all of his the supplies he was carrying because he didn't have the consignment note on him as to say where this thing had come from or where it was going, right? So just briefly here, the life cycle analysis look at the environmental aspect of an organization, products and services. But if you watch it carefully, it's through the life of the product from upstream to where did the steel come from to make the washing machine? Where did the plastic come from, right? Who painted it? What sort of paint they use? The transport. So that's what I tell you. It's literally like a document that's handed over from extraction then to final disposal. Final disposal could be if you watch it, the user is using it, but at the end, the customer is using it. And at the end of that, the customer, like, remember in the UK, you kind of think, well, you could think Trinidad and the Caribbean, but remember, I guess if anyone is not from the region anyway, most of our, appliances would end up probably in the dump, right? It wouldn't be recycled. And in fact, it may end up on the side of the road, right? In a sort of, bushy area anyway, right? Most of your used washing machines, it may end up in Claxton Bay or whatever, Claxton Bay dump, right? Or the Beaton. But if you're from South Trinidad, it's probably going to end up in Claxton Bay anyway, right? Claxton Bay is a dump, right? So, but not in the UK. I'm saying that it has to go back to like a recycling firm, and then the final part of that consignment note then will be, taken in by the recycling company. So if you turn the page, they do have this again. It's here, but again, I know this is very small. The book has it on page 33, right? If you could just read this, this and the one before is the same thing. This is just a bigger view of it, or should I say a surface view of it. And then here they went into, like what they mean by supplier. If you read the top of it, extraction and production of raw materials such as steel and plastic. If you go back, you'd see here was steel and plastic, right? So let's see, and just see if you can see what I'm telling you, that in every phase, they want to consider what is the source, pathway, receptor, impact, right? However, they didn't fit all of that here as how it's done for the degree. They just put the end of it, right? So they have the source then, iron ore mining, steel production. We can say the impact is habitat degradation, dust and sulfur oxide emission, water pollution, suspended solids. Let's talk about transport, right? When the raw material is being transported from the mines. So see how this is when they say cradle to the grave. Imagine if we could ever get our environmental management to something like this, right? Sort of like how B&Q had done it in the UK, tracking back where the trees were coming from, so tracking back where your steel is coming from, right? Is it coming from Jamaica? Is it coming from Trinidad? Is it coming from where again? I guess a lot of places have steel plants anyway, right? Is it coming from but the US has a lot anyway, right? So if you're looking at transport, the use of lorries, rail, wagons, ship, fuel consumption, the output is engine emissions, right? So at every part of that, I see what is missing here would have been you had to put in here then the source, pathway, receptor, and work out the risk assessment, right? Let me just, I think I saw Joel, let me just, right. So, yeah. Right, so someone is coming in. So let's go to the last piece of it. The last piece of it, which is what the last two pieces. So consumer. So we do use. Everyone has a washing machine. Everyone has televisions and whatever have you. Again, I mean, for those who know me a bit, I mentioned to you, I do try to be a little bit environmentally conscious. Like I had a TV, I would say, that went bad. I had it repaired and I used it, and it went bad again, I think this year. And I didn't just put it by the road or toss it away then. In fact, I actually did sort of give it to someone who was repairing TVs anyway, so they could find some use of it. I did not take any monies or anything for it, right? So just things like that then, like, so somebody using the washing machine, consumption of water, consumption of electricity, all of these are how we impact the environment. Consumption of detergents, right? And then the output could be power station emissions, wastewater runoff, the power station runoff, because remember, we need electricity to tell you how we are all dependent and we are all sort of, responsible for pollution in the long run, right? Anyway, this is the end of it. This is the piece I said that really don't happen too much in the Caribbean. So you have like the last piece of it, disposal of the washing machine. So use of road transport, use of a break-in machine, and hopefully this is in a what is called what was what they're looking for, a sustainable dump. So they have your land degradation if it's been broken down on a sustainable dump, engine and power station emissions. But then there are companies that will take that. I think I saw one this week I mean, just what come to my mind, I saw someone this week, I don't know if you all saw it on Facebook too. They took like old, just old cans, old Coca-Cola cans and Pepsi cans and 7-Up cans, and they heated that up and they got back the metal from it, and they used the metal to form, I guess, into like a vessel. We would call it a basin in the Caribbean here, right? They use like a silver basin, right? But it's a vessel, and they made it literally. The people looked as if they got it from just picking it up on the side of the road, and they were able to recycle it, right? So, of course, in the UK, I mentioned that they are, like much more recycling plants than we have in the Caribbean anyway. So, the last piece of it, like when they say it ends up on a dump, it's not like the UK version of a dump. It's not what we would call a dump, right? There are sites then designated as like sanitary landfills, and I don't have time to go into it now, but the point is that they have been designed for that, right? I'm just going to show you something in it. A sanitary landfill has been designed to be a landfill. It's not just a piece of land that you say you're going to make a dump on, right? You're just going to throw things there and you say that's a dump. But a sanitary landfill, and the base of it has been fitted with impervious material. They are like pipes running. You can say out of it, but it could be from it as well, like this. And those pipes are meant to flare the waste gas, like the methane coming out of that, right? So there's a difference between a sanitary landfill, one that has been designed to be a landfill, and one that is just a piece of land that ends up being eventually people throw, or dispose of materials there then, right? Washing machines and old television sets and refuse and stuff. And it ends up just being a dump, and it grows to be a big dump. But that is not the idea of what that's not the idea they have here anyway in the developed countries, right? All right, so that was a little bit too much because I don't think anything there is coming for exam. It's just I had to run through this slide. um if you look, like I said again, at page 34, you'd see the same thing, but the thing is that hopefully y'all understood the piece I spoke about before, that at the other levels then, right? Or if you're doing this for real in a company, you want to go ahead and put out all the headings then, right? The input, then you want to put, I guess that could be the source, the pathway, the receptor, the impact, you work out the risk, you put in the controls, etc. Right? But I have seen, I don't know if the question is there, I'm not seeing it in the book, but I have seen the ask, what is the cradle to the grave concept? Like which best describes the cradle to the grave concept? I don't know if it's in the book or it's in the past papers, but the answer is one that really takes care of contaminants or a product then from inception to final disposal. That's sort of the idea behind it. And if you wonder how they did it, I mentioned to you there is a document that goes from the manufacturer to the supplier to the employer or the owner of the company, the hardware, whatever, then to the consumer, then the consumer gives it back to the not to the retailer, but to the recycling company. It's called a consignment note anyway. And remember what I said, in some countries, this thing is law, and the failure to have it could actually be punishable then with a fine, as I mentioned for you, the one on Ice Road Truckers. The guy did get a fine and his truck was seized. They had to come and like pay money to get the truck released and all of the services and stuff in it. All because he forgot the note that had to be passed on. I guess he was the transport, but to the person receiving, and he had actually made the journey. For those who looked at Ice Road Truckers, how difficult those journeys are. He had actually made the journey, but didn't have the consignment note, and for that, you can say then, for want of a better phrase, he was truckless. Then I remember him having standing up there, and they had to send somebody for him because they seized whatever he was moving. Right? I think we answered this already last week, but last week's session was not recorded, so maybe we could answer it again. Which would constitute an environmental aspect. So we're looking for what is a source, which of these is a source? I think the answer we said would be car exhaust emission. And this is the best answer here, right? So yes, we know it's the engine and stuff, but at least it's the closest answer here. Ozone depletion is a effect, which makes it an impact. Acid rain, same thing. Dead fishes, same thing, right? All right. Sources of air pollution, right? Now we have two of these to do. So but these don't have so much of explanation as what I just did there. That had the EIA had a lot of explanation in it, right? So we have two of these to do. Yes. I think it's just remember if any. I know you're signing with Galaxy E71.
Michelle, sir.
Yes.
So, with regards, a few minutes ago, you mentioned the cradle to the grave past paper question. So I just find the question. Could we answer it as a on it already?
Where is it? Is it in the book?
No, it's on the past paper that you sent us.
Well, I don't have mine on me. You want to read it out first and we could answer it?
Right, so it's question 7. The
Mm-hmm.
cradle to the grave concept applies to the life cycle analysis of the manufactured products considered from impacts from A, the main manufacturing process, B, the use by the consumer, C, the past, present, and future impacts, and D, the final disposal of the product.
I guess it'll be C, right?
Past, present,
Yeah,
future.
past, present, future use of the product. Yeah. I do have the passive though, but I mean I don't have it on this view anyway. Hopefully, if we finish, I could look at it, right? So yes, so thanks for finding that question. Like whenever I say there's a question, there is a question. It's not as if those things are. Whenever I remember something, I know it is a question, right? So even if you don't have it in front of you, whenever I say there's a question like there's one here, right? There's one coming up here too, but even if I don't have it in front of me because we're on this view anyway, you can still write it down and then go look for it like what Misha would have done there, right? All right, let's go into sources of air pollution. For that, you're gonna have to turn the page, of course. So this will line up with page 35. Um, so we have sources of air pollution. They just, if you have your book, you see the same headings. They have like energy consumption, but we just saw that, by us using machines. And, the thing though is that I was saying last week, I don't think you should feel too bad about it because a lot of this is at least modern society anyway. But you could use less of something and you could actually purchase. We saw that concept already, like more, like sustainable washing machines. And most of us have. If you would have purchased anything recently, a refrigerator, you'd see it have a label on it called energy save. So then those are the better ones. We cannot really in this society then, do it out, refrigerators and washing machines and microwaves. We may have to in the future, right? But at least in the modern society, really for the last, America and England, I think the Caribbean may have gotten more developed over the 80s, right? But really and truly, America and England, they had all these modern conveniences maybe the maybe the latter part of the 30s, believe it or not. If you look at any old American shows, you'll see it, right? I remember, for those of us who, of course, hear that even in the later 70s, 80s, not everybody in Trinidad had electricity. Not everybody in Trinidad had running water, right? If you had one TV, everybody would in your village would come around that anyway, right? Anyway, so energy consumption, most of the world's energy still comes from burning fossil fuel, and fossil fuels is on page 35. So it's derived from fossilized plants deep beneath the earth. There's a question here: write down as many types of fossil fuels you can think of. Well, we don't have to think about it because the book give you all of it on page 36, right? Is it page 36? So this, I was saying, this is a question here, like like which is not a fossil fuel, right? So this page may have something for you to learn because remember, it's multiple choice. It's only if they ask you like which of the following are fossil fuels. But then if they give you all, then the answer will be like D, all of the above, right? So fossil fuels could include coal. Here, what I'll just read some because it's a long list, right? We have anthracites, and they told you what that is on the book as well. Anthracites, very high quality coal with a carbon content greater than 90%. You have lignite, low quality brown coal. They have coke. They told you what coke was here. Solid residue made by heating coal in the absence of air. Of course, some of the more common ones, fossil fuels, yes, petrol, gasoline, diesel, I kind of read it all, natural gas, LNG, LPG, right? I was thinking it had another one, but I didn't see it in the book, right? Okay, so if it's not there, it's not there. Let me just move on, right? There is another one. There's actually one called peat, P-E-A-T, right? Peat, but if it's not there, it's not there, right? So I'm gonna leave it anyway. I mean, for your exam anyway, if it's not there, it's not there, right? So getting energy from fossil fuel releases carbon dioxide, heat, and light. Um, Highly toxic materials may be released, including lead and mercury, and some radioactive substances. Now, um, anyway, I'll move on. Some of that, like this, the lead and the mercury really comes from like the derivatives then from the fossil fuel, right? So like plastics then, of course, you know, plastic is a derivative from oil, believe it or not, right? Plastics is polyesters and polystyrene and stuff. They are all derived from oil, right? But if you do burn plastics, which you're not supposed to be burning plastics and styrofoam, then you release the toxic materials into the air per se then, right? So some of these in the natural form do not really release toxic materials. This is why I pause a bit. Is really when you burn them, like the product, the made product from oil, polyester, right? Clothes and whatever have you, polystyrene, right? Uh, like if you burn those, then you find toxic materials being released anyway, right? Anyway, they have some on the other page, so let's go to that. They have some of the main contaminants there, sources of air pollution, and they have the industry and the air pollutant. You'll find it on page 38, those who have the book and following. The thing about this too, if you look at the table, page 38, you'll see that most of the contaminants are the same, right? You could just look through it and you'll see like oil and gas refining, we get particulates, sulfur oxides, nitrogen oxides, volatile organic compounds, VOCs for short, benzene, hydrogen sulfide, hydrogen fluoride. Just drop down to any other, you'll see something very similar. If you go into pulp paper manufacturer or manufacturer, we have particulates, we still have VOCs, we still have, well, we have some new ones here, chloroform, formaldehyde, ammonia, but some of them then are like consistent. It's like once you do, once you sort of have these in your reactors, fossil fuels, then it almost end up with the same set of contaminants. Waste incineration, particulates again, carbon dioxide, sulfur oxide, SOx as they call it, and NOx as they call, these here, NOx, hydrogen sulfide, hydrogen fluoride, right? And of course, just for anybody who have a little bit of chemistry here, why did they use those things? Like why did they use SOX and NOx, SOx and NOx, right? So why they use that is because the numbers could change. X then is like maths, X is equal to different numbers. So you could get, if it was a 2, it would be sulfur dioxide, right? By itself, it could be sulfur oxide. So if you put a 2 there, NO2, it becomes nitrogen dioxide. If you put a 3, it becomes nitrogen trioxide, etc., right? So there are different oxides then of nitrogen and different oxides of sulfur. So they use the X there to symbolize different numbers. even the word particulates, in case I know some people don't know what this is, you may think about particles, but particulates is actually not particles. You may think of things floating in the air. In a way that may be true, but particulates is actually short for saying PM, particulate matter, right? PM, particulate matter. And the ones that could be released here, you have PM10s, and you could have less than PM10. A PM10 is a particle like with a size, the micrometer in it, the micrometer size is about like 10 micrometers. And let me tell you why I said that, because you may not have realized why I said that, right? Particulate matter, could I say greater than 10 micrometers is like the ones you could see with your eyes. These normally make up what is called um, inhalable dust. Inhalable dust is like if you can see dust, like if you, I guess you were sweeping the yard, or some flower fell, or maybe where you are working, you're seeing dust. Well, that's inhalable dust, right? Now, inhalable means you can inhale it and exhale it, right? Sort of maybe without too much bad consequences, other than it probably having some sort of effect to your system then, right? But the point I was trying to make here is that particulate matter greater than 10 could actually come out of your lungs. It doesn't stay in the lungs then, but PM10 is less than 10 micrometers, the other way around. If it's less than 10 micrometers, it's described as respirable dust. What was I trying to write there? I forget what I was trying to, I think I was trying to put inhalable there, right? But the one less than 10 micrometers, it's described as respirable dust. And if you know that phrase, respirable means that when you inhale it, it stays inside of your lung, right? So if you go back and you track some of these things here, you'll find like when they say particulates, right? If it's less than 10 micrometers, then it could stay within the lung, affecting things like respiration, maybe developing in things like lung cancer, etc. Right? So don't think of particulates as anything less harmful than the rest of them. It is just as bad as all of them anyway, right? So I was like, over the years we tell students like they could bring this for you and say like which of the following are contaminants. Let me just finish up the story, right? So like which of the following are contaminants from cement manufacture, right? So I was like, when we first brought this course to Trinidad, we were telling students that, so then like make sure you learn, like the particulate matter, the carbon dioxide, the sulfur oxides. But the truth is they never brought that. So that level of detail then, if you get what I'm saying, the level of distinction between one industry to another industry, they never brought a question on that. To say that you had to know, okay, then like benzene was coming from oil and gas, and it's not coming from pulp and paper. They never did anything like that. They never brought any question that refined, right? I'm trying to come to the question still, right? So, like I said, remember the first year, that would have been 2014, when we brought this course to Trinidad. At that point in time, I didn't have any question paper and stuff, or should I say past papers. But even from then to now, they have never brought that level of distinction. So what I would tell you, just make sure that you know some of the bigger ones like particulate matter, VOCs, SOx, NOx, right? And that could be applied to any one of them because they have not like distinguish one industry from the other one to say that you have to know then that hydrogen fluoride is some waste generation and it's not from cement manufacturing, right? They have not gone into that level of detail. I wish I had more time with you all because there's so much of nice things I'm seeing here. I would just mention them. And hope that somebody know what I'm talking about. I don't know if you all know anything about benzene, toluene, and xylene. These three are seen under cement manufacture here, right? Just to make a long story short, if you'll get some time, you could research something for me called BTEX. BTEX, and you'll be amazed to know what you find about BTEX, right? BTEX, well, I guess from it you could predict what I'm saying, that B is benzene, T is toluene, the E is actually ethylene, which is not on the list, and with the X is xylene. Research that and see what you come up with. You'll be surprised to see what you come up with, right? So I'm going to leave that there because it's not, it's not on the lesson anyway, right? Plus, I've already overspoken a point. I'm moving on, right? Just to get the slides to move, right? So types of air pollution. Remember, in case I forget, again, remember, if anyone wants, I know Joel at one point in time wanted to do this degree, but remember when I say you have to kind of weigh the pros and cons of it. In Trinidad and Tobago, not a lot of companies are hiring you with an environmental degree. So you kind of do that after you'd have done your safety degree. That's just the reality of this country, right? That you have more work for safety than for the environment, right? But remember, we do have access to it, but you'll be on your own, right? You have access to it through a UK provider, and they will see about you, right? I mean, if anybody wants to do that, but you'll be on your own anyway, right? Types of air pollution. So this is still in your book, I think. Types of air pollution. You have next page, of course, page 39, right? We have smoke, dust, grit, fumes, fibers, and those make up particulates. Again, I'm just wishing I had more time, because if you look at this very carefully, what they are saying, then remember the thing I just said about PM10s, right? That PM10s could be fibers. You may wonder, well, what kind of fibers? The answer is asbestos fibers, right? PM10 could be dust. How could PM10 be dust? It could be silica. If you know what silica is, a form of dust. And silica is described as, well, a particulate matter with a size less than 10 micrometers, right? So just be careful of that smoke, dust, grit, fumes, fibers make up particulate matters. If you want and you have your book, you could write that on the side here. They may have it in the book too, come to think of it. I'm seeing fibers there. Let me just read fibers for you. Particles that have elongated shape. Some fiber particles are very dangerous. So we have it there, asbestos fibers, right? So like I said, you can never tell if they give you, what category of pollution does asbestos belong to, and they give you particulate, gas, vapors, mist. The answer is going to be particulates, right? So we have gases, which we already mentioned, some like the NOx and the SOx. We have vapors, and we have mist as well. A mist is different to a vapor. If you read the book, you'll see it a bit. A mist is normally like a liquid droplet. To give you an image of what a mist is like if you have, which we all have, I guess, some sort of like a deodorant, right? The Axe deodorant, or you have, and you spray, if you just spray that on a glass, what you'll see, you'd actually see liquid droplets. If you have a bug spray, right? Whatever bug spray you have, if you spray a bug spray onto a glass, you would see droplets, right? So once something has liquid droplets in it, if you watch your book, find liquid droplets, it's described as a mist. They actually said fly spray there, right? And vapors, you'll be shocked to know that vapors actually have, vapors may actually have, at least some of them, well, I'll probably take it from the book, right? So substances in the gas phase, but which are normally liquid at everyday temperature and pressure, right? So mostly like steam and stuff may fall within that. Like, for those who know, there are two types of steam. So like wet steam could be described as a vapor. Wet steam, right, is like a mix of steam and some droplets at the same time anyway, right? So we have odors on this one here. Odors is used in relation to type of air pollution. Pollutants may be released deliberately via chimney or accidentally via leaks in pipework. unplanned releases are called fugitive emissions. Now, on this one slide, it have two past paper questions here. So we had to slow down a bit, even for me to tell you what it is, right? Let me see if I can see them if they had them here though. If they don't have them here, then it means it would have been really from a past paper, right? So I'm not seeing them here, right? So normally would have been right or wrong there. I don't think it's much further than that. All right, so let's go back. So what you could do, you could paraphrase the question that I'm going to give you. And right, just quickly with this, right? So just quickly with it, right? So in one of the sittings, they had asked, which of the following is not, you could write it down. I'll just make it up. It might be the same question, but it is, I mean, it might be the same answer, but it is the same question. They ask, which of the following is not a type of air pollution? And if you have your book, you could just to go fast, you could just watch page 39 and page 40 and see if you could get the answer. And of course, it was only 4 answers, right? But because I have 4 here, 1, 2, 3, 4, 5. So which of the following is not a type of air pollution? Because it's a very funny question, isn't it? Because the heading is types of air pollution in your book. But when you read it, right, what you'll see, anybody have the answer? Which of the following? If they give you this, if they give you, I'm just going to pull out 4, right? I'm going to pull out particulates, odors, gases, vapors. Which are the following 4? Which of the following, which one in the following then is not a type of air pollution? So that was the question. And the correct answer inside there. Particulates, odors, gases, vapors. I just used one from the other one and I just took off mist then. Anybody have an idea? I guess you could guess. If you want to guess.
I say odors, sir.
Right, the answer is odors, right? If you just go to page 40, you'll see it. Now, please remember that is a past paper question. I just rearranged the answers then because I can't remember, but odors was there and 3 other types were there, right? Page 40 says, I read it from the book, right? The term odor is also frequently used in relation to the types of air pollution. This describes the offensive smell that many air pollutants can cause rather than the physical form. In other words, then, I guess sulfur dioxide have a smell, right? Ammonia has a smell, but the smell itself then is not the type of air pollution. That's what they're trying to say. The odor itself then is not a type, but the odor is a characteristic of the type of air pollution, right? So I was hoping not to use one that's strange to you, but if you know, like welding have a fume, it have a smell then, right? It have like a metallic smell. So the fumes is a type of air pollution, but the smell of the metal itself is not a type of air pollution. So the answer will be odors, right? So quickly, next one, I mentioned there are 2 questions on that same slide. Some slides are not like that. We can talk about this whole day and there are no past papers there. But this one have 2, right? So the other one is this one. The other one is fugitive emissions. Now these things come in every sitting. They give it like 4 statements and they ask you which is a fugitive emission. So let me just read back what I have here. They had unplanned releases are called fugitive emissions. So if there is a chimney and I guess something escape, maybe some contaminant escape, that is said to be a fugitive emission. Now, one of the strange things here is that the word emission is not taken to be strictly related to the air. See if you understand why I said that's strange. It's strange because the heading is air pollution. It's strange because the heading is air pollution, but the word emission or how they bring it for exam sometimes have nothing to do with air. It have to do with water, right? So the reason for that those of us with the book, is that that actually happened before in 1984 in India. There was an occurrence known as
Well, you know
Bhopal.
what a Rastaman is about now, so you'll see what others be talking about.
I just have to mute the background noise, right? Yeah. All right, yeah. So I was saying in Bhopal, India, there was a case, just a long story short. I don't know which would be shorter, for me to explain or for me to read. I guess I could read. That may be the shortest, right? In 1984, a Union Carbide Corporation factory manufacturing pesticides in Bhopal in India leaked around 30 tons of toxic gas into the atmosphere. The leak was caused by a process failure when water accidentally penetrated a tank holding that the toxic chemical metal isocyanate. Now, again, just realize that they are talking about water now, right? But it's still going to be classed as fugitive emission. The resultant chemical reaction caused the temperature and pressure in the tank to rise dramatically. You have this in your book, eh? And toxic gas was vented through a pressure relief valve. The toxic gas drifted, but it became a cloud. For those who did process it, it became an unconfined vapor cloud. It drifted over a local residential area. In fact, that's not quite true. It probably is kind of true, but it did drift into like the slums in India, right? Um, Causing deaths and serious injury. Estimates vary, but it is thought around 8,000 people died and 30,000 suffered severe injuries within weeks of the incident occurring. So because of that, there is always a question about fugitive emission. But what I'm saying is that you have to be careful, because sometimes, if it is go back to the book, they don't link it to air pollution, right? They link it to like a leaking pipe or something. And it's just like, just think of it like that, like wherever something, like if it was an oil tank and the tank leak oil into the river and that wasn't planned, in a way, that is fugitive emission. Let's look at your book a bit. Page 40, they have they actually give two. They give, I think they give one with air and with water as well, right? So pollutants may be released deliberately into the atmosphere, example via chimney. Well, that's not fugitive emission because that's deliberate, right? They may also be emitted accidentally, example leaks in pipe work when a volatile liquid is being decanted. So a leak in a pipe is said to be fugitive emission. Now, if you have your highlight, you can highlight that because that is the answer they give for the exam. Which of the following is a fugitive emission? They have some leak in a pipe work. They will give you a better statement though, but it is some leak in a pipe work. That is the answer for fugitive emissions. If you're looking for air pollution in the answer, remember the heading here and in the book is air pollution, but fugitive emission doesn't have to be confined to the air then, or I guess the air is unconfined, but like specific to the air, right? It doesn't have to be, it could be relatable to liquids as well, right? They say here, think about the petrol vapor you can smell as you fill up your car. These unplanned releases are known as fugitive emissions. So that may be another one. But the one I've seen, when I say maybe, because I've not seen that one with the car petrol and the fume we're getting from off that, the one we have seen is a leak in a pipe work, and that is the answer they're looking for fugitive emissions, right? So I had to kind of pause a bit there to run through those two past paper questions anyway, because at the end of the day, remember, those are the things that are coming back. I'm going to speed it up a bit now, right? The last piece of this is on the hierarchy of control. Remember, I mentioned that once you do a risk assessment, the risk turns out to be high, you do have to control. And most of us here would know the safety risk assessment. But on page 41, you have what is called the environmental sort of hierarchy then. Remember, like most of us know the hierarchy for safety: eliminate, substitute, engineering control, administrative control. PP is last, but for the environment, the approach they use is somewhat similar. You have to eliminate, minimize, and then render harmless. So you may want to memorize that. Again, just a quick one here. If they ask you, like out of the three of them, suppose they ask you, right? Like, what is the second option? in the hierarchy of, like, I'm just going to say dealing with the environment, right? It could be waste management or air pollution. What is the second one? You'll have to say minimize, right? Render harmless is last. So it'd be best if you learn that. It's sort of like the environmental hierarchy that starts off the same way as a safety hierarchy. Eliminate, minimize, render harmless, right? So let's see what they have here. So I think they're going to give you some examples. Control of air pollution. I guess they're trying to, I'm going to break some of this down, right? So think of a car, maybe it's best to use a bicycle instead. Remember, there are certain parts of the world they do that. In fact, right here in the Caribbean, they do that. You could actually find me. No, I'm joking, right? I actually do cycling every evening, right? But right in Grenada, people do use bicycles a lot. Cuba, that's right in the region here, people do use bicycles a lot. And of course, if you would have traveled, China, Singapore and stuff, bicycles are what is allowed in the capital city, not cars anyway. Singapore, right? Bicycles. We do it, I said right in the Caribbean here, Cuba, Grenada. If you go across, they'll be shocked to see that a lot of people are on bicycles. It's like a normal thing anyway. Trinidad, it's looked at, it's looked at as if you don't have anything if you have a bicycle. I have one. Just to give you a funny little one, I normally go to the shop. There's a shop about 5 minutes from here. Not even so long, but about 2 minutes from here. But like I would normally go with my bicycle, and I remember a Sunday I went with the bicycle, and someone was telling me, hey, don't worry, you'll get a car soon. Right? And so that's how it's looked at, I guess, in this part of the world, right? So that's an example of eliminating control equipment, clean exhaust, and dirty air before release. Now, this may be here with maybe minimizing. You may want to forward your pages a bit with this one. Control of air pollution. Now, this is on around page 43. So here they are using something like in terms of minimizing or maybe even rendering harmless, right? I would probably say minimize though, because I don't think this is really render harmless. You have different means of purifying the air, right? So again, it's up to you, I guess, if you want to learn any one of these. You have gravity separators, cyclone. Let me read all for now. Try to describe it in a bit, right? Fabric or bag filters, electrostatic precipitators, wet scrubbers, and adsorption. Right now, looking at the time too. What you need to know, right? Just a minute, draw some like a factory. What you need to know, right, is that all of those things, in a way, it's linked to like the exhaust emissions then. So all of these, even if they say treatment, to be honest with you, these are like a filter, right? So just watch me a bit here that each of these, I'm going to make it in a way that you'll understand it, right? It may not really be like that, but each of these are like filters. So like as the emission go through the different types of filters and clean it, so then what comes out here is a purer supply of air, right? Again, it's just more time that I need, right? Now, the simplest one is the fabric or bag filters. If you look at them, there's some words actually saying the word filter. What you really need to know is that all of these are like a filter. So the fabric or bag filter, that one, it will have in it just like, what's the word I'm looking here for? I guess that you would understand something like, well, you must know what a filter is, right? If you don't know what a filter is, you must see a filter before. If it's a water filter, I mean, there are like holes in it, right? So there are holes in it. And with the fabric bag filter now, to the bottom, like why they say fabric bag is like there's going to be like a collection pot. This one may be in the form of a bag. So as the air goes through, if you look at it, they say things are like small particles would not be able to go through. They'll drop back and they'll get into the bag, right? They'll drop back into the chimney and get into the bag. So again, I've not really, I mean, you could probably, that one is the most common one. The fabric or bag filters is used for the removal of small particulates, right? The others are a little bit more complicated, right? But I will still try, but I feel this may take up the time if I go into this, right? But I could mention them briefly and see if I could still move on to something else, right? So let's just say that it was the one called electrostatic precipitators. Watch on the slide a bit. This is the quickest way for to get it. If we say this was electrostatic precipitators, what they will do, they would actually charge the filter. They induce a current in the filter. Now, the electrostatic precipitators don't look like that though, but the idea was going to give you was the idea of a filter, right? But they charge it. So let's say they charge it positively charged. In other words, and whatever this is here, it don't have no holes in an electrostatic precipitator though. Electrostatic precipitator is solid, right? But they would charge it. So it's positively charged. A charge is either positive or negative. I'm saying positive. And then what they will do, they'll actually run a current here through this airflow. Current, as you know, is negatively charged. So what is going to happen is that any contaminant that was here, I'm going to draw a dust, the contaminant will pick up a negative charge. The way they write it is minus VE, right? So current is negatively charged. You're going to run a current stream through there. They're just going to like connect wires and have a, just run current through it anyway then, right? So whatever is passing through here is going to become negatively charged, but the filter is positively charged. So what is going to happen is that, as you would know, negative is attracted to positive, so that the contaminant, let me just try to take out that filter from there, right? Would actually go and stick on the filter, like, I guess, you know, fly paper. And what they will do with that electrostatic precipitator, they will actually like wash it out, then they'll take it up and they'll wash it out at the end of the day. That's how an electrostatic precipitator works, right? So you could run through the rest of them. Cyclone is almost the same thing. The only way to do cyclone, if I take out the filter again, a cyclone is like this, but the base of the cyclone, sorry, the base of the filter is like this, which is why they call it a cyclone, right? So the air moving through that takes up that sort of shape then. It takes up the shape of a cyclone. Let me just try to draw a bigger cyclone, right? It takes the air moving through that filter looks like that. So what happens is that the dust particles, if you look at cyclone, right? Cyclone is used to remove large grit particles or dust particles, right? And so it takes on that shape because the filter has a cone to the bottom of it like that. And then the larger dust particles, just like a cyclone, gets, you know, whirled around, but then it settles to the bottom of the filter, right? So there'll be like, again, like some holes there. Whatever make it through here then wouldn't be able to come back, sort of like a vacuum anyway, right? So again, I have not seen any questions on that. I just wanted to kind of touch on it to tell you that all these means of sort of minimizing the consequences to the atmosphere was all based on different types of filters, and they work with different principles. Some of them work on the principle of gravity. Some of them work on the principle of how the air flows through it, like a cyclone. But you have to know that's because of the shape of the filter, right? It kind of creates like a funnel. The electrostatic precipitators are the weirdest one because you have to induce two current flows, both positive and negative. Wet scrubbers uses water, like a jet of water to wash it down, and absorption uses like a dissolving material to absorb the contaminant in it as well, right? So all of those are means of purifying the air. Let me try to move on a little bit more. We may be almost out of time. This class feels like my class yesterday for the diploma, right? When you feel as if you're now getting into the work, the time is up. And I mean, it has really been an hour and a half, but again, it doesn't feel like that. At least for me anyway, it doesn't feel like an hour and a half. I seem to have lost my, the thing to change the marker back. Okay, yeah. It doesn't feel like an hour and a half at all, right? All right, let's see where we are at. Maybe I can stop here. I was hoping you would have heard me say at the top of the lesson, I was hoping to get into water pollution, but that doesn't look as if that's happening anyway, right? let's try to finish off this. Let me see how far away are we. Wow, we're pretty far away from it still. The only way to would be to read it out. 5 minutes again. Let me just read them out, and I'll try to do any sort of explanation if it have, because I think we had described these already. The effects to the environment could be grouped as both local, regional, and global. We may have mentioned this in lesson 1, right? So I'll kind of simplify it now that I see what it is. So local effect could be like the acid rain destroying local vegetation. Local effects could be like air pollution causing people to get asthma and whatever have you, right? Just like in the local area though, right? Regional effects is if, it goes to another country. So oxides of nitrogen and sulfur reacts with moisture to make acid rain, damaging trees, soil, and lake ecosystems. It is thought that around 20,000 lakes in Scandinavia have been affected by acid rain, with 40,000 being so acidic that no life can survive in them. Regional effects. Acid rain can also lead to structural damage. Dust and particulate matter can be transported over hundreds of kilometers. The indiscriminate burning of rainforests in Indonesia has created episodes of severe air pollution in Singapore, where smoke and debris from the fires caused a thick haze over the city lasting many weeks during 2013. And of course, those of us in Trinidad here could remember when the Beatum was on fire. Well, it was purposely so anyway, but it had, Port of Spain, anyone who was working in Port of Spain, the capital city anyway, had to be vacated. You couldn't go to work. The air quality was so bad, even in, I guess a Caribbean country here. So the effects of air pollution, global effects, climate change, and ozone depletion are now the top of the international agenda. Please remember that's two different things. Climate change have to do, this is global warming. If you remember, I had drawn this for you all the first class. The sun rays come in and then it should leave, but with the increase in CO2 levels, they get trapped closer to the Earth's surface, which is causing a heating up of the Earth's surface. Remember ozone depletion, I didn't really do much on that, but ozone depletion is not the same as global warming. Ozone depletion have to do with a layer of gas in the stratosphere that is being depleted, and that the name of those gases is called ozone, right? I'll talk about that maybe next week again. Climate change, there's little doubt global warming and rising CO2 levels are linked through the greenhouse effect. The greenhouse effect is the heating up of the Earth's atmosphere globally. Some radiation is absorbed by greenhouse gases. Man-made emissions are believed to enhance greenhouse gases. Ozone depletion, the ozone layer absorbs some UV radiation from the sun. It's called UVB radiation, by the way. Ozone depletion is caused by emission containing CFCs, that's chlorofluorohydrocarbons, chlorofluorohydrocarbons or carbons, halons, carbon tetrachloride, and metal chloroform. The Montreal Protocol on substances that deplete the ozone layer was laid out in 1997, right? So the question here, and I guess I'll stop there and I'll go back if I have a minute. I don't know if I have a minute, I'll go back. I have 2 minutes, right? The most important source of air pollution in the world is what? See if we could answer this one. I'll take back ozone depletion next week, because well, I guess I could just do the question with you, or maybe that'll be the best thing instead of this question is on page 48. Anybody could guess what is the most important source of air pollution in the world? A, B, C, D. It would be D, burning fossil fuels, right? I was trying to link this to a question. Just to link it to a question, right? If you were asked which of the following is an ozone depleting agent, then, right? Let's hope they have one of these, right? CFCs, halons, right? There's a whole story on halons. So those who know, halons used to be used in extinguishers long time, fire extinguishers in Trinidad, right? It's banned around the world. I still see some in Trinidad. Some companies, you go to old companies, not old companies, but companies that sort of have old extinguishers, then you still see heal on extinguishers, right? Anyway, the thing here is that the ozone depleters, I'll end with this, right? I'll end with this. Let me just set something up here, right? So I wouldn't have to repeat it next week, right? It'll be I was going to repeat it, but I see from this week to next week, time goes by and you all sometimes may forget. So remember what I said, the ozone layer is like a layer in the stratosphere. It is made up of something called ozone. And if you didn't know what ozone is just 3 molecules of oxygen, right? So by the way, ozone at ground level is bad, but the ozone layer, could probably put the sun up here somewhere, right? So the sun, the ozone layer is 3 molecules of oxygen that exist in the stratosphere. And what that does, it filters out a type of UV radiation called UVB, right? UVB radiation. And so that what comes to the earth then should not really have that amount of, like UVB radiation in it, etc. Right? So that's the idea with the ozone layer. But I wish again you could confirm some of these things I'm telling you. But again, this is to tell you that it have more than just a level 2 course here as well. That around 1960 to 1970, 2 British scientists, they were doing some work, I think, in Antarctica, Alaska. Could have been Alaska, to be honest. I don't think it's Antarctica, right? And what they found out, they were releasing something like a colorful emission into the air, whatever, and they were tracking it, right? And what they realized was that it was actually passing through when it should not have passed through, like that layer. Then it should not have passed. It wasn't supposed to pass through that layer of gases, right? And those 2 scientists, if anybody know their name, their last name is Roland. That's how you could find them on Google, Roland and Molina. They are the ones responsible for this whole thing, of saving the earth and climate. They were awarded, by the way, the Nobel Peace Prize, Roland and Molina. You can just put them, if you just start putting Roland in Google will just bring up Roland and Molina for you one time, because like I said, they are that famous anyway, right? Because they were the ones who spotted the fact that it had a hole. Well, as you say, a hole, and it's not really a hole, but it's like missing gases then that should have been in the stratosphere, right? However, just a long story short, the year was 1970 and no one took them on. I don't know if you know that. 1970, the earth then, like what were people doing? You had civil rights. You still have civil rights in America, believe it or not. I mean, still fighting for civil rights in America. But since 1970, the Caribbean here was very much influenced with, like Bob Marley and trying to remember Haile
Stokely
Selassie.
Carmichael.
Say again.
Stokely Carmichael.
Who's that?
Black Panther. Black Panther.
Yes, yeah. So the Caribbean was, so 1970 people were more about rights and, especially in the Caribbean. So no one really wanted to hear these 2 British persons talking about when you were fighting for civil rights in America and it had the Vietnam War thing going on at the same time. It was still actually the Cold War with Russia was still going on. Long story short is that by the time people started to take this thing seriously, it was about 1990. And by that time, they found out the hole in the ozone layer to be the size of Antarctica, and I think they say South America combined. If you just watch a picture, I have a globe here. You just sort of watch how big that is. I can't find that for you now and talk to you at the same time, right? But the size of South America then, right? The Caribbean is the size of South America and Alaska combined, right? That was how much gases was missing, right? So around the 1990s, those who were around then, you realize that there was a lot of emphasis now on advertising and deodorant companies banning ozone and like CFCs then banning the CFC compound. I said ozone, so my mistake, but banning CFCs in the latter part of the 90s. But, you know, they say it was a bit, kind of a bit too late already because a lot of gases had been depleted, right? So anyway, I just want to show you this last thing here that I was saying for exam, if they ask you anything about like a ozone depleter, could I take off Roland and Molina name, right? You could just put that in Google when class finished, right? And you'll see, I think they were awarded the Nobel Peace Prize, but it wasn't in 1970. Yeah? It's like when people started to take them seriously, then they were awarded that Nobel Peace Prize many, should I say, decades afterwards, right? Anyway,
2020, sir.
19?
I think it was 2020 that was awarded the Nobel Prize.
Okay, all right. Anyway, that's a lot of years, some from the years of the initial discovery to tell you. But imagine, I guess if, but you know, the Earth, like I said, was, it's kind of like now we're more concerned with the pandemic. Who knows if they have something like asteroids? It have scientists are saying it have asteroids out there, right? But no one really taking that on, no one really taking on asteroids, right? It's just like that. It's like in 1970. Yeah, these two British guys found that, but everybody was about civil rights and stuff. Anyway, back to this. I was saying for exam, if they give you any depleter with, what you need to realize is that these things have chlorine in it. What makes the depleter that way is the fact that it have chlorine in it, and halons actually belong to the same, in the periodic table, the same, you know, category of chlorine then, right? So carbon tetrachloride is actually CCl4. Metal chloroform, well, I don't know how to draw that for you. It's drawn like this. They use something called a benzene ring with chlorine attached to it, right? The point is here is that what they have found is that most of the ozone depleters then is actually chlorine is what is killing all these gases, right? So what makes CFC bad is the chlorine content to it. What makes carbon tetrachloride bad is because it's the chlorine content to it. What makes metal chloroform bad, I may have drawn this one wrong. I can't remember my chemistry too much, but I think it's something like that. But it should have CH in this too, to be honest, CH4Cl or something, right? Because metal is CH4, or CH3. Just remember my chemistry. CH3 is metal. So metal chloroform is CH3Cl, right? But the point is, it's not the CH3 then. It's not that. It's actually the chlorine what is responsible for destroying the ozone layer. And watch me as I finish now. What they say is this. They say one chlorine, they call it an ion, right? When you split chlorine and you get the, for those who know what I mean, split chlorine supposed to be Cl2. But when you look at it here, it's just Cl. So this is described as the chlorine ion. The chlorine ion, ION, right? That's what this is described, a chlorine ion. What this says is that that one chlorine ion there that I have drawn, just think about what I tell you now from 1970. Yeah, that chlorine acts like Pac-Man. That's what it does. It will go and eat every one of this here. And from 1970 to now, it's still up there eating the ozone layer. But I've just drawn one chlorine ion. That is what the chlorine does. It eats the O3, it breaks down the O3 then. So from 1970 to now, this one chlorine ion that I draw there, of course, you know, it wasn't one, it's probably, I mean, this is millions and millions and millions, right? What it does, it feeds on the ozone layer, like Pac-Man. It eats and it keeps on eating more and more chlorine. So we'll finish class with that there, right? I don't know if anybody have a solution, you know, well, I mean, they have banned it. I mean, they have banned, you know, CFCs then, should I call it that? Or products containing chlorine. But the thing is what they do, it's kind of like a plastic bottle then. It's kind of like if you ban plastics in Tobago, remember it's still have plastics in the sea. I guess in the sea it may be easy to probably take some kind of net and pull it out, right? But remember, plastics don't degrade. A plastic bottle on the planet now will still be 100 years from now, 1,000 years from now. So that CFC that is up there is still is up there. Maybe you could think about that if you also like this field. Think about, I have a solution, right? I have a solution, but I wouldn't share it today, right? I have a solution, but that is where I think the money is in terms of the environment, right? That if we could find a way to restore some of those molecules, I think believe it or not, Bill Gates and them said they have a way to actually go on of course, we know like everybody know like Bill and Melinda Gates, as well as I guess people like Jeff, the owner of Amazon. I think they said they want to go and seed like new molecules then, right? I don't know if they're gonna carry, maybe have it and maybe they have it in some vessel or something, but new ozone molecules and deposited there. But what's happened to the chlorine? Isn't the chlorine gonna keep on eating it? Right? Anyway, anybody you could think about that as the class finishes here today. If there is a way to help us, right? I mean to help the world, right? For those who you know, for those who could see into the future, right? When I say see into the future, it have some men on it have people on with channels then, right? I don't know if you know a channel called Apex, APEX. These things do make it to the weird side of the news sometimes, but it is reported. That's the other thing. Apex News is reported. It have people who say they can see into the future, or they are time travelers and they come back to our time. I'm just telling you what is reported on Apex. So you can make sense out of it or not. And they all seem to claim that the earth is flooded. The earth is, well, not probably all the way flooded, but it's more flooded than, and the whole cause of it is global warming, right? So remember, all of that is sort of linked to global warming a bit. So if it is just prediction or common sense that you can just predict that if the layer of protective gases is gone, more sun, the UVB rays is coming in. So predictably, that may be a good prediction. But there are people who make a life out of it. I saw one this week. I see some very strange things on my phone. Just sometimes I manage to tell you all about. I saw one this week. Someone actually said he had a pity of California, and he actually had it. And if you all saw it, it was reported just on Google News, whatever. He came back with a pity of California, and he was showing you parts of it that was flooded. They could not disprove the picture. It was not a Photoshop picture anyway. But as I said, for those who can see the future or just make sensible predictions that in the future, then certain places that we know now may be flooded because in the past, certain places that were above ground is below sea level today. Any questions as I end? Like I said, there is such a fascination with the environment. I'm sure you all are picking that up and mentioned that for you all. There's a fascination with the environment. However, the fascination sometimes in Trinidad doesn't translate into a job. It's just a fascination, right? Let me just get a rule here. I'll just mark it down. And if you have any questions, you could ask, right? In terms of exam, I mentioned, I just writing it down. So I would try to get, well, based on NEBOSH, the Galaxy A71 is Michelle, right? Yes, I think that's Michelle, right? Vanessa, right? The environment is a nice field, but like I said, sometimes they don't translate to jobs in this country, or your job end up being testing for water contaminants whole day or something. Shiva was here. I'm not seeing him now though. Anyway, so I should probably stop the recording, right? Stop that.